Here's a review of the midterm exam. First one was supposed to be an easy one. 1 plus 1 is 2. Carefully convert the equations to well-formed, grammatically correct sentences, no symbols. So this first one, 3 points, initial velocity, you can tell initial because that 0 means initial, and then 37 meters per second. So 1 point for each underline. This is the weight force, or weight, is 650 newtons. M stands for mass. Some of you put meters, which wouldn't make any sense. So mass is 67 kilograms. Now, convert the sentences to mathematical expressions. So the V final, 2 possible symbols, either just plain V or V with a subscript F. So is 37 meters per second. Displacement has to have the delta in it, so delta x is 3 centimeters, and then position has no delta, and then to the left is negative, and then 3 meters. Okay, and points 2, 2, and 3. Student is interpreting position versus time graph. Units on the y-axis are meters. Units on the x-axis are seconds. Units of the slope, so that's going to be meters divided by seconds, and that is the unit of velocity. Slope, remember, is y divided by x. Hey, how many seconds are there in exactly 4 hours and 12 minutes? Must show all work to get any credit. So supposed to do the train tracks. So we start with, there are a couple of different ways to do it. This is how I did it. So 4 hours, I converted it into minutes, and then minutes into seconds, and I got 14,400 seconds. And then I took the 12 minutes, converted that to seconds, got 720 seconds, and then added 14,400 and 720 and got that value for the seconds. Some people found that in minutes and then added it to 12 minutes and then converted that to seconds. So there are a couple of different processes that I accepted. 3 points, 1 for converting to seconds correctly, 1 for this seconds correctly, and then adding them together to get the final answer. 22 total points on this page. All right, next question. It's supposed to be an easy one. Spell initial. All you had to do was spell initial to get a point. Which of the following is closest to 1 meter in length? So we have used the meter sticks, so you should know the meter sticks. It's about the height of a desk. Penny, way too small. Length of the classroom, way too big. Diameter of the moon, really way too big. How many significant figures? So this does not have a decimal, and so that trailing 0 is not significant. So 2, 3, and 2. This one, because there's a decimal, this trailing 0 is significant, so that has 4 sig figs. Leading zeros are never significant, they're only placeholders, so that has 1 sig fig. Middle zeros are always significant, so 1, 2, 3, 4, 5. And then again, trailing zeros, no decimal point, and so there's only 1 sig fig. So 1 point for each of those, 5 points total. Allie takes this many minutes to swim 2.4 miles, 400 minutes to bike, and 603 minutes to run 26.2 miles, which answer shows her total time with the correct number of significant digits. So we need to convert that one into whole numbers only, because this is a whole number, and so we're just going to, because we're adding, we're just going to do add whole numbers, and so I add those together, and I get D. Object's motion is displayed on the line graph shown. So the first thing we need to realize is this is a velocity versus time graph. All the values are negative, and so this is moving to the left because it's negative. Here it says right is positive. And then the velocity is going from -2 to like -5, and so the speed is increasing. So 2 points, 1 for each box. Using the one-dimensional coordinate system, show how an object can have negative displacement. There was not like a single correct answer. You just needed to show something like this. I told you how to do it. Show initial and final positions. So here's my initial position. Here's my final position. I also had to have both of those to the right of a 0. So I needed to have at least 3 points on my coordinate system. And then you also had to show displacement with a vector. So you had to show the arrow going from the initial position to the final position and still being positive. So 1 point for labeled number line, 2 points for x initial, x final, and then 1 point for showing a displacement arrow that was negative, but with x final being positive. Okay, number 12, so starting at -2, -4. So you had to show that position. You also had to have kind of a labeled coordinate system. So x in centimeters, y in centimeters, and then you needed to put at least 1 hash mark, show the x initial. The thing that was key is recognizing that this is a displacement, it's not a point. So my displacement went, this is the one in pink, went +2, -4, so that is my second position is right there. And then my second displacement went -2, so this is in blue, -2, and then +8. So this is my last position. And so the final position is going to be 0, x, and -2y. Sorry, -2x, 0y. I know my y's and my x's. Also, I directed you to put in the arrows. So that was worth 4 points, 1 for each position, and the arrows. Okay, and this page was worth a total of 18 points. Okay, next one, bald eagles captured using the motion detector on the graph. Use the graph to answer the following questions. Okay, what is the distance traveled? So here's my initial position at time 0. My final position is 0, and so the distance traveled is 200 meters. Final speed, so speed is going to be a constant speed because this is a straight line on position versus time. And so we take our total distance, which is -200, divided by our time, which is 24 seconds. We just read that off the graph. 200 divided by 24 is 8.33. Because they were asking speed, the negative didn't matter, so that's this one. Our speed is constant. It's a straight line on position versus time, and so constant speed, acceleration is 0. Bald eagle is moving to the left. My displacement is negative and moving at constant speed. What holiday is celebrated on December 25th? Christmas, worth a point. Okay. All right, car starts at a position of -4 kilometers, moves to a final position of 4 kilometers. What is the displacement of the car? So I just drew a number line. I started at -4, I went to 4. That's a total displacement of 8 kilometers. A ball is +5 meters from the origin and moves -6.9 meters. What is the ball's final position? So again, I drew a number line. I started at 5. I went 6.9 to the left, which means 5 minus 6.9 is -1.9. So that's a point. Helicopter is lifted off and is hovering above the ground. So it's hovering above the ground, which means it's not moving. That means I have to have balanced forces. So I've got earth, helicopter, air. This one definitely has to be labeled FW. I took a variety of labels for this one, but definitely not F normal, because for normal you have to have 2 solid surfaces touching each other, which the airplane is not touching anything. So you needed to have a free body diagram. Downward force is FW. Upward force, you could just label it F. So you got 2 points, 1 for each arrow, and 1 point for them being equal length. They have to be equal length, otherwise not hovering. So the total for this page was 17 points.